equations. How many types? How many types of linear equations are there? Homogeneous system, other is non-homogeneous system. For this particular type of system, always consistent. What do you mean by consistency? A system of equations is said to be consistent if it has a solution, if there is at least one solution. For a homogeneous system, you see, x equal to 0, y is equal to 0, z is equal to 0 is definitely get solution, isn't it? So there will be no question of getting the circumstance of no solution. Definitely it possesses a solution, always consistent. Okay, in this system, only two cases arise. What are the cases? One case is unique solution, infinitely many solutions. Infinitely many solutions. This is about homogeneous system. Well, non-homogeneous system, and here it is again two cases: consistent, inconsistent. Consistent, inconsistent. Inconsistent means no solution at all. You forget this case, you leave it. If at all it is consistent, it has again two cases. What are the two cases? Unique solution, infinitely many solutions. This is the clear-cut picture of the system of equations. Well, to avoid confusion, we shall look at these equations separately. First of all, we shall deal with the homogeneous system of equations. If a homogeneous system of equations is given to us, we are sure to have a solution. What is the solution? Zero solution is a solution. What I mean to say is x equal to 0, y is equal to 0, z is equal to, that is whatever variables present in the system. You take every variable 0, that becomes a solution. That is also called a trivial solution or obvious solution. Isn't it? And we may have to check whether it has another non-zero solution or not. If at all it has a non-zero solution, there will be infinitely many. There will be infinitely many solutions. Yes, of course. Well, and when can you decide that is a unique solution? When can you decide that there are infinitely many solutions? In this case and this case also, we may have to learn very carefully. Now, let us focus our attention on homogeneous systems first. Consider 3x plus 4y minus z is equal to 0, 5x minus 2y plus 3z is equal to 0, 8x plus 3y plus 4z is equal to 0. This is a system of three equations in three variables. What is the number of variables? 3. Well, my dear, this can be expressed using matrices like this: 3, 5, 8. What are all these? Coefficients of x. 4, minus 2, 3. What are all these? Coefficients of y. And minus 1, 3, 4. What are all these? Coefficients of Z into the column matrix X, Y, Z is equal to the column matrix 0, 0, 0. This matrix has been obtained by grasping all the coefficients of the variables in the three equations. That is why this is called coefficient matrix. What is this called? Coefficient matrix. This is of course called variable matrix, and that is of course called value matrix, which we are not interested actually, and we are very much interested in knowing about coefficient matrix. First of all, do you mean that it is a homogeneous system or a non-homogeneous system? Homogeneous system is equal to 0, is equal to 0, is equal to 0. Well, my dear, let me call this coefficient matrix as capital A, this variable matrix capital X, and this is column matrix is 0 matrix. What is the standard form of a homogeneous system of equations? Ax is equal to 0. As and when we like to discuss with the system of homogeneous equations, theoretically we consider the system to be Ax is equal to 0. What is A? Coefficient matrix. What is X? Variable matrix. 0, value matrix. There are some crucial points here. Number 1, Ax is equal to 0 is always consistent. Since x is equal to 0 is a solution, which is a trivial solution. Second one, Ax is equal to 0 has trivial solution as the only solution if rank of A is equal to number of variables. Second rule. First point is, there is no problem of inconsistency in the case of homogeneous equations. The system is always, by birth it is consistent because x equal to 0 is a solution. Of course, that solution we read it as trivial solution. The problem is it the only solution or is there any other non-zero solution that we want? So two cases arise. Ax is equal to 0 has trivial solution as the only solution, that is unique solution, if and only if rank of A, I think you could have recollected this symbol, rank of A is equal to number of variables. The third and last point, Ax is equal to 0 has infinitely many solutions, if and only if rank of A is less than number of variables. Rank of A is less than number of variables. This is about a homogeneous system. The first point, of course, we need not remember. By birth it is correct, of course. For any homogeneous system there will be a solution. No question of inconsistency. They are always consistent. X equal to 0 is a solution. The second and third points are to be noted. Suppose rank is equal to number of variables. Unique solution will be there. Rank less than number of variables, infinitely many. The only plus point that must be kept in mind, rank is equal to number of variables, unique solution. Rank less than number of variables, infinitely many solutions. That's all. Well, let us make it clear by going through some examples. This is the given system. This has unique solution, infinitely many solutions, no solution, none. These are the options. One thing is sure, no solution is wrong. This is a homogeneous system. Definitely zero solution is a solution. Now, this is not subjective test, objective test. You gather A. What is A? 1, 1, 2. 3 minus 2, 5. 4 minus 1, 9. Come on. 1, 1, 2. Let me take R2 changes as R2 minus 3R1 and R3 changed as R3 minus 4R1. 3 minus 3, 0. Minus 2 minus 3, minus 5. 5 minus 6, minus 1. 4 minus 4, 0. Minus 1 minus 4, minus 5. 9 minus 8, 1. So first step is over. Second step, all the entries below 2 place. This is again 1, 1, 2, 0, minus 5, minus 1, 0, 0, 2 by R3 changed as R3 minus R2. What is the rank of this matrix? 3. How many non-zero rows are there? 3. As the rank is 3 and the number of variables is also 3, there is only one solution. What is that solution? 0, 0, 0 solution. Isn't it? Therefore, Ax is equal to 0 has x equal to 0, y is equal to 0, z is equal to 0 is the only solution. But dear friend, another benefit in this system is, this is a triangular matrix. What is the determinant? Minus 10. Det A is minus 10. Det A is minus 10. There are so many benefits. If you want to have the determinant, you just apply these 2 steps. You have the determinant directly as the product of diagonal elements. Yes. Therefore, this is rank is 3 because determinant is non-zero. 3 by 3 minor is non-zero. So rank is 3 because that is the largest order in this. Therefore, rank is 3 is equal to number of variables. Isn't it? That is why it has unique solution. On what basis you are able to say this? Rank of A is equal to 3 is equal to number of variables. In this system, you have multiple benefits. You can, if you want to have, you can have the determinant also here. What is the det A? Minus 10. The system is consistent. No doubt it is homogeneous. How many? How many solutions are? Only one solution is there. What is that solution? Unique solution, that is x equal to 0, y is equal to 0, z is equal to 0. Okay. Next. One more. What is this system? What is this system? What is the type of this system? What is A? 3, minus 4, 5, 2, 5, minus 3, 7, 6, minus 1. Isn't it? Okay. If at all there is 1, we shall feel happy to make these 2 zeros. Let us make this 1. R1 changed as R1 minus R2. 3 minus 2, minus 4 minus 5, 5 minus of minus 3, 2, 5, minus 3, 7, 6, minus 1. Now you apply R2 minus 2R1, R3 minus 7R1. 1, minus 9, 8. What are the operations we have planned? R2 must be changed as R2 minus 2R1. R3 must be changed as R3 minus 7R1. 1 minus 9, 8. 2 minus 2, 0. 5 minus of minus 18, 23. Minus 3 minus 16, minus 19. 7 minus 7, 0. 6 minus of minus 63, 6 plus 63, 69. Minus 1 minus 56, minus 57. This is again 1, minus 9, 8, 0, 23, minus 19, 0, 0, 0. Why? Because R3 changed as R3 minus 3R2. What could you notice here? What could you notice here? Come on. What is the case with this? Number of non-zero rows is only 2, but the number of variables is 3. Therefore, rank of A less than number of variables. Less than number of variables. Therefore, how many solutions will exist? Infinitely many solutions will exist. Do you want to see those infinitely many variables? Do you want to see? It's not impossible. By means of this system itself, we can rewrite the system x minus 9y plus 8z is equal to 0 and 23y minus 19z is equal to 0. From this we have 23y is equal to 19z or y by 19 is equal to z by 23. Suppose you substitute 19k in the place of y and 23k in the place of z, you will have x in terms of k. That gives you a solution for every k. That is why it becomes infinitely many solutions. You see, it's at rare cases only we might be asked the way of solutions, but we are just supposed to tell the nature of the solution only. How many solutions will exist for this one? Infinitely many solutions will exist for this system. We have seen two examples. In the first example, there has been a unique solution only, and in the second example, there might be infinitely many solutions, isn't it? Okay, good. Let us observe another corner in this one. Observe this problem. He himself has given that this system has infinitely many solutions. What does it mean? Rank of the coefficient matrix is less than 3. Less than 3. But what is the coefficient matrix here? What is the type of this matrix? 3 by 3. He is saying that rank of the coefficient matrix is less than number of variables. Who told you? Array, it has infinitely many solutions, isn't it? When can you have infinitely many solutions? When and only when the rank of the coefficient matrix is less than number of variables. Therefore, rank of A less than 3. implies 3 by 3 minors are zeros. Det A is equal to 0. Okay, instead of finding directly det A, let us use the procedure. 1, 2, minus 1. 3 minus 3, 0. Minus 3 minus 6, minus 9. 5 minus of minus 3, 8. 4 minus 4, 0. Minus 1 minus 8, minus 9. Lambda minus of minus 4, lambda plus 4. Isn't it? Lambda minus of minus 4, lambda plus 4. 4 minus of minus 4, minus 1 minus 2, lambda minus of minus 1. Good. Again, 1, 2, minus 1. How could you get this step? R2 changed as R2 minus 3R1. R3 changed as R3 minus 4R1. 0, minus 9, 8, 0, 0, lambda minus 4 by. At this juncture, we use our thinking capacity. See, rank is 2 or less than 3, he is saying. That happens when and only when number of non-zero rows is less than 3. So this must be a 0 row. For that, lambda minus 4 must be 0. So lambda is equal to, this is one way, and the other way is det A is equal to 0. Det A is equal to 0. Lambda minus 4 into 1 into minus 9 is 0. Lambda is 4. Whatever you like. From this itself, we can have the determinant as we could have mentioned in the beginning itself. In the beginning itself, we could have noticed that even from this form, we are able to have the determinant. What is the determinant? 1 into minus 9 into lambda minus 4 is equal to 0. Thereby lambda is equal to 4. Or you can have the determinant directly from here itself. You decide which procedure is easier. I do not mind. This is the way to look at the questions regarding homogeneous equations. Isn't it? Okay. One more. Now it is our turn to look at non-homogeneous equations also. Later on we shall come back to deal with some more special properties of rank. Now it is our turn to look at non-homogeneous system of equations. What will be the standard form of this system? For example, you consider the equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. And this system can again be written as a1, a2, a3, coefficients of x, b1, b2, b3, coefficients of y, c1, c2, c3, coefficients of z, hence it is a coefficient matrix, and x, y, z, variable matrix, d1, d2, d3, the constant matrix or value matrix. Let me call this I, this x, this b. Therefore, this system can always be considered as x is equal to b. One of the most important items here is you are supposed to form a new matrix called augmented matrix. What is meant by augmented matrix? In the coefficient matrix A, the fourth column is also introduced, that is the value matrix, as the fourth column. This is referred to as augmented matrix AB. My dear friends, it is not the product AB. A beside which B is present. That's all. This matrix has a great importance in this system. What is that importance? What do we take the decisions regarding solutions? That we may have to understand. We have made a trial to represent the general form of non-homogeneous system like this. And now it is our turn to tell about the nature of solutions. Let the given system be Ax is equal to B. Two cases will arise. What are the cases? Consistent, not consistent. If the system is not consistent, there itself the chapter is closed. There is no more discussion at all. Okay, how to identify that the system is not consistent? Rank of augmented matrix not equal to rank of coefficient matrix. If that happens, that is, you are supposed to find two ranks. Yes, of course. But actually we do not find. We find the procedure, we apply the procedure only once, and it will be made clear if you go through some examples. While solving the examples, you can make the things clear. Don't worry for the present. In order to notice that the given system of non-homogeneous system of equations is inconsistent, you must observe that rank of AB not equal to rank of. Okay, suppose they are consistent. When do you say that they are consistent? Rank of AB is meant not the product AB, augmented matrix AB is equal to rank of A is equal to small r. Say, in this case again, two cases. First case is R is equal to number of variables or less than number of variables. In this case, unique solution will be there. In this case, infinitely many solutions will exist. Observe the picture very carefully, my dear. In the case of non-homogeneous system of equations, how many cases will arise? Consistency and inconsistency. In order to test or in order to recognize that the system is consistent, you must notice that rank of the augmented matrix AB is equal to rank of A. If this does not happen, that is, if rank of AB is not equal to rank of A, then the system is inconsistent. Throw it away in the dustbin. It will have no solution at all. No question of any discussion. The discussion will take place when and only when there are some solutions. That is, if rank of the augmented matrix AB is equal to rank of A, then only the system is consistent. Consistent means it is supposed to possess some solutions. Now the question arises. Solution exists. System is consistent means solution exists. How many solutions will exist? Is it one solution? Is it unique solution or infinitely many? The two questions can be answered like this. If the rank of the coefficient matrix is equal to number of variables, you recall the same concept is explained in the homogeneous system also. If the rank of the coefficient matrix is equal to number of variables, there is a unique solution. Here also, there also, unique solution. If the rank of the coefficient matrix is less than the number of variables, then infinitely many solutions exist. Well, my dear, I would like to suggest you, my dear boys and girls, you observe these two cases. These two are exactly similar to that of homogeneous system. Isn't it? This is the picture of non-homogeneous system. In order to remember them well, in order to recollect them quickly, let us have entire information at a glance in the form of a tabular form. Yes. Observe this tabular form. We have two types of systems. Homogeneous system, that is Ax equal to 0, and non-homogeneous system, that is Ax is equal to b. Inconsistent. When can they be inconsistent? No question of inconsistency for this system, always consistent. This will be inconsistent if rank of A be not equal to rank of A. Consistent if always consistent, but this is consistent when and only when rank of the augmented matrix AB is equal to rank of A is equal to some RC. Unique solution. When can they have unique solution? Rank of A is equal to number of variables, rank of A is equal to number of variables. You observe the similarity. When can they have infinitely many solutions? Rank of A less than number of variables, rank of A less than number of variables. You observe the similarity. The only change occurs here. Consistency and inconsistency. Isn't it? This is a beautiful and useful tabular form that one can learn and keep in mind so as to recollect the concepts regarding the nature of solutions of linear equations. Follow them very carefully. Now, let us focus our attention on non-homogeneous system of equations in view of an example. Consider a system of equations. X plus y plus z is equal to 6. 2x minus y plus z is equal to 3. 3x plus 2y minus z is equal to 4. Okay friend, what is the augmented matrix here? 1, 2, 3, 1, minus 1, 2, 1, 1, minus 1, 6, 3, 4. Up to here, this is A, and if you adjoin that, it is AB, augmented matrix. Let us proceed in our usual way. This is equivalent to 1, 1, 1, 6. 2 minus 2, 0. Minus 1 minus 2, minus 3. 1 minus 2, minus 1. 3 minus 12, minus 9. 3 minus 3, 0. 2 minus 3, minus 1. Minus 1 minus 3, minus 4. 4 minus 18, minus 14. I think you could have understood. R2 changed as R2 minus 2R1 and R3 changed as R3 minus 3R1. First step is completed. What is that first step? All the entries below 1/1th place made 0. All the entries below 2/2th place, this is to be made 0, isn't it? For this, let me interchange these two so that here we have minus 1. 1, 1, 1, 6. 0, minus 1, minus 4, minus 14. 0, minus 3, minus 1, minus 9. What type of steps I have taken? R2 and R3 are interchanged. Now again, we can make this 0. How? 1, 1, 1, 6. 0, minus 1, minus 4, minus 14. 0, minus 3, minus of minus 3. 0, minus 1, minus of minus 4. Minus 1, minus of minus 12. 3 times, isn't it? Minus 1, minus of minus 12 is 11. Minus 9, minus of minus, it is 33. Stop there. Why should you stop there? There are no more entries below 3th place. Close this. What do this part correspond to? A. What is the rank of A? 3 non-zero rows are there. You take all the columns. What is the number of zeros? What is the number of non-zero rows? 3. So what is your observation? Rank of the coefficient matrix is equal to rank of the augmented matrix. What is your opinion? It is consistent and has a unique solution. How do you say that it is unique solution? Is equal to number of variables. Okay. Do you want to have the solution? You can directly from that system. 0x, 0y, 11z is equal to 33. 11z is equal to 33. Therefore, Z is 3. Now, make use of this row. Minus y minus 4z is equal to minus 14. Minus y minus 4z is equal to minus 14. That is y plus 4z is equal to 14. But z is 3 we have got. 4 3s are 12. If it goes that side, y is equal to 2. Oh, happy. You substitute these two in the first row. 2 plus 3, 5. Goes that side, 1. So x is 1. That's all. So, all the pieces of work have been completed. We have tested it for the consistency. If you consider all the columns, rank of the augmented matrix AB can be observed. If you observe only first 3 columns, rank of A will be observed. So in a single step, through a single procedure, we will be able to have 2 ranks at a time. So that rank of AB is equal to rank of A. System is consistent. Okay, equal to how much? 3. What is 3? Number of variables. So that is equal to number of variables. Hence the system has how many solutions? One and only one solution. What is that solution? Do you want to have? You can from the last step itself. 11 z is equal to 33. Z is 3. Minus 5 minus 4 z is equal to minus 14. Substitute the value of z. You have y. We have got y and z. You take both of them to get substituted in the first equation. X is obtained. That is the beautiful way of producing the solution and taking the decision about the number of solutions and about the consistency also. And this concept will be strengthened in your mind when and only when if you are able to solve as many problems as you can. And for this part, I would like to give you one more question. Try to get it solved. Let us both try to get it solved here itself. Come on, take the problem. This is the given system. Come on. We are to take the decision. You need not put any steps. We directly go to the augmented matrix. What is the augmented matrix? 1, minus 1, 2, 2, 3, 1, 3, 15, 2, 2, 1, 13. 3 minus 1, minus 1, 2, 2, 3 minus 3, 0, 1 minus of minus 3, 4, 3 minus 6, minus 3, 15 minus 6, 9, 2 minus 2, 0, 2 minus of minus 2, 4, 1 minus 4, minus 3, 13 minus 4, 9. Oh! I think the decision is ready. What is your decision? What is your decision? These two are equal, isn't it? So if you apply the further procedure, this becomes 0. Do you want to see it? You can. 1, minus 1, 2, 2, 0, 4, minus 3, 9, 0, 0, 0, 0 by R3 changed as R3 minus R2. This is a peculiar case, my dear. You consider all the 4 columns. A rank of the augmented matrix is 2. You consider just first 3 columns. Rank of A is also 2. Here also, rank of AB is equal to rank of A is happening. No problem. What is the specialty here? Less than the number of variables. Less than the number of variables. Ultimately, what is the result there? What is the result? The system has infinitely many solutions. The system has infinitely many solutions. Do you want to have the infinitely many solutions? The shape of the solutions? It's simple. You take any one of the variables, say z is equal to some k. 4y minus 3k is equal to 9. 4 is equal to 3k plus 9. Substitute here. y and z, you will have x. Isn't it? Right. Like that, in terms of k, you will have a lengthier solution. That is infinitely many solutions. We could have taken the decision by means of rank of a matrix without using bulkier procedure. We have just have 2 steps. All the elements below 1/1 place, all the elements below 2/2 place. That's all. By this simple making, our decision is ready. Our decision is ready. So it has infinitely many solutions. In the previous problem, we could have had unique solution. In the present problem, we have infinitely many solutions. Let us now have one more problem. Let us have this system. What happens to this system? Again, let us proceed as usual. 1, 2, 1, 4. 3 minus 1, 2, 4. 4, 1, 3, 5. Apply our usual procedure. 1, 2, 1, 4. 3 minus 3, 0. Minus 1 minus 6. Minus 7, 2 minus 3, minus 1, 4 minus 12, minus 8, 4 minus 4, 0, 1 minus 8, minus 7, 3 minus 4, minus 1, 5 minus 16, minus 11. How could you get this step? By R2 changed as R2 minus 3R1, R3 changed as R3 minus 4R1. Again, entries below 2/2 place. 1, 2, 1, 4. 0, minus 7, minus 1, minus 8. 0, 0, 0, minus 3. Come on, dear. What is happening here? You observe. You consider just the first 3 columns only. Rank of A is equal to 3. You consider all the columns. Rank of AB is 4. As there is a non-zero entry, this is also a non-zero row. The number of non-zero rows is 3. Hence, rank of AB is equal to 3. Therefore, rank of AB is equal to 3 and rank of A is equal to 2. Therefore, these 2 ranks are not equal. Therefore, AX is equal to B is inconsistent. It has no solution at all. It has no solution at all. That is it. That is a matter of linear equations. Of course, there are so many theoretical questions regarding the same. We shall be looking at in due course of time.